the solid R bounded by the circular cylinder x squared plus y squared equals 9, and the plane z equals 0, z equals 1, x equals 0, and y equals 0 is shown in the following figure. Find the transformation T from a cylindrical box S in R theta z to the solid R in XYZ space. So we're going to find the transformation from S into R to the space XYZ that we see here. So this is R here, and we have to find the transformation from S to R. And it says in the space R theta z. So hopefully that brings up a clue here as far as how to start this. So X is equal to R cos theta, y equals R sine theta. And honestly, this is most of it here. This is the big idea here that we're pulling into this. The idea of polar is what we're using here. And that's what R theta z is. It's not polar, but it's cylindrical. So that's what we're going to use here. So we have our T, and that's going to be R theta z. And our X then is going to be R cos theta. Our Y is going to be R sine theta, and our Z is going to equal Z. It's really just that fast. Now, one thing about this as well is we have to look at the parameters for S here. So we have to describe S. What is S? So think about our theta here. So what is theta? Theta is in cylindrical where I run from the positive x-axis counterclockwise. So I'm running this way. So how far does that go? It goes from 0 here to pi halves. So theta is going to run from 0 to pi halves. So I'm going to say S R theta z. And then my y, or I should say my theta, I'm just going to write it down here, is going to run from 0 to pi over 2. And my R, my radius, is going to run from, using this one here, that's R squared equals 9, because remember our other formula, x squared plus y squared equals R squared. So since that's 9 there, that means my R is going to be 3. So my radius is going to run from the origin all the way out to 3. And then what's going to happen next is I got this theta that's going to swoosh it around to cover up the whole area there. And that's how that polar or cylindrical is going to work for us here. All right, so it's going to be 3. So my R is going to be from 0 to 3. And then my theta, will it fit over there? Nope, I'm going to have to put it down here. Is going to be from 0 to pi halves. And then my Z is here. It's Z equals 0 and Z equals 1. So my Z is going to be from 0 to 1. So there is the region S. Now if I had to graph this, and I will, because I want you to see this region here. This region is going to say, hey, on the R, I'm going from 0 to 3. So there's my 3. And from my theta, I'm going from 0 to pi halves. And my Z is going to be from 0 to 1. And then if you look at this picture, I'm really looking at a rectangular prism. And using this rectangular prism, I can calculate this volume if I wanted to. And that transformation is taking this transformation to here. And this here is my S. And that's what I'm looking at. So I would actually calculate here. And then I would use a Jacobian and times it with my integral. And then I would find the volume of R if that's what I was looking for. So that's the idea here. But I didn't need any of this. For the answer, all I need are these two pieces here.